ceremony, we start the recorder and then we click, got it. Welcome to the March edition of the Silicon Valley Fourth Interest Group monthly meeting. It's now, I guess, the World Fourth Interest Group monthly meeting. Thank you to the internet and to Brad and to Bill and to all of the folks that have made it so, with dubious nods to, with grateful nods to Dennis and Dennis Rufer and others before him. And it must be terrible to be senile and forget people's names, but I wouldn't know because I've forgotten what it's like. So without further ado, let's get into our program. Bill, introduce yourself and on with the show.
Very good, gentlemen. I use that term advisedly. If we can move all the little pictures around here, get them out of the way. Very good. The topic today is ways to do structured the output formats for floating point numbers. It's been a sore point of mine for a couple of months because I was doing some work earlier on matrix math and matrix support for fourth, and all the numbers I was using were floats, and I could not get them all to line up to make pretty reports. And so that was an open topic at that time. And recently I dug deeply into Win32 fourth, and I mean deeply, and kind of cracked the code. So let us begin. So a problem that I had, as I just mentioned, was Win32 fourth only provides a modest output for floating points. You can specify the number of digits and then use F dot, and you will get that number of digits in your display, but you have no control over alignment and decimal point. It happens where it happens. And so this is an example. If you set the precision to 6, your output will be to 6 significant digits, but the decimal could be at the left, middle, right, depending on the number itself. But I can't align these and I can't stack them up based on right justification. So the first test that I did was I wanted to specify decimal alignment. This would be like handling money. You want the decimals always to be vertically. And example of what I want was this. We have the number 1, 2, 3, decimal 4, 5, 6, and I want to output with the decimal points all in a vertical line. And if you'll notice, the very first number at the top is rounded to a -1 point decimal significance. So the 123 is rounded to 120. The next one is rounded to the integer amount, 123, and then so on down the line. And we'll notice about rounding. We'll comment on that a little bit later. So this was my intended output. So I wanted, also my need number 2 was right justification. In that case, what I wanted to do is I didn't care where the decimal was, but I wanted all the numbers to align depending on the precision I'd specified to the right. And I will note that the first couple of entries, when we round off to less than to integer values or less, we're off by 1 space. And so I know where to go find the problem. I just never got around to fixing it. So I noticed this fairly late in the process, but that one needs to be tweaked over by 1 decimal point or 1 output point. So the key to this, I found out, was the word represent, which is an American National Standard fourth number, word. New to me, I had not gotten involved with the later strokes of the ANSI standard, but in research, I found out that to use the word represent, you come with a floating point number and you specify a conversion address where you want the output to be, and a number of significant digits that you wish. So if you want to go to max precision, you could make n be 15, or you can make it on some number smaller than 15. And in this case, then, in your buffer space, you will find n digits converted, and you'll get on the flag, on the stack, the exponent represented by that text string, the sign if it's positive or negative, and then a flag indicating correct conversion. And the flag, I believe, is false. There has been a conversion error. It turns out that the way ANSI fourth uses represent, the flag has already been checked. And these are for extreme cases like not a number and negative infinity and so on. And the error has been checked, but the flag is still given there for correctness on the ANSI standard. So in this case, we're going to get n number of ANSI bytes. If you say n is 10, you'll get 10 ASCII bytes in that buffer space, contiguous with blank filled at the end and no decimal shown. Here's an example. 123.456 is a floating point. I have a buffer called scratch, and I want to represent 8 numbers at that point. Next step down is the dump at scratch, and we see the ASCII 31, 32, 33, 34, 35, 6, which represents numbers 1, 2, 3, 4, 5, 6, and it's blank filled at the end with 2 blanks to be the total requested of 8 digits. And simple as this is the key to doing all number output. So we see in this case, we would get 3, 0, minus 1. The 3 means the decimal point is 3 places from the left. So it's located between the 3, 3 and 3, 4. 0 means it's a positive number, and minus 1, it says correct conversion. So I will make an observation, good for just the discussion value, that 132.4 uses an innovative cryptic, takes a lot of head scratch to figure it out method, which allows it to pass local array workspace between words. Normally, a local array is only legitimate within a single word, but to avoid creating a text buffer for floats, they create a local array and then use that, passing that address between words, so that when the conversion is finally done, there is no fixed output. This becomes a problem because if I want to use this in a very general way, I do need a buffer space that is globally accessible, and I work that out. So here's an example of this obscure operation. The paren FP dot word has a temporary buffer called $buff. It is assigned in the middle to a local array. Max string, I believe, is 15 digits. So it's a 15-digit. Actually, max string is 255 characters. So it creates a 255 character buffer called $buff. And then invisibly, that is passed to another word via the execute. So that's the start of the little cryptic mystery on how this is processed. So we will discuss this sometime in the future, maybe. So our right justified example. This is the code that does the right justified, paren f.r. We give it the overall field. If we wanted in a field of 12 digits, say, with leading blanks supplied, we would put 12 for the field. Decimal gives us the decimal fraction. Say we want to do money, so we would have decimal would be 2 places. And after this executes, we'll receive the address where that conversion has been done. So the initial portion, the first 2 lines, use represent. And this is only to get the exponent. But I found out that that's all I needed at this point. Well, I need to know where that decimal point is, where the decimal point is going to be. Then I use the built-in fourth conversion, the paren f dot. Paren f dot paren does the conversion, and I have set to use the string buffer at pad. So not using the obscure method that's built into fourth, I just do that simple string conversion into a buffer. And then finally the do loop places the leading blanks. So the paren.f does my conversion to the proper number of decimal points, and then I pad it with leading blanks. So the overall word generates the right specified string, gets me the exponent, f dot paren formats the string, and then we add the leading blanks. And then the basic word generates the string, but does not display it. It just gives you the address of the conversion. And so in this case, f.r just does the count and type. So this will allow you to put in trailing blanks, or you could add in a $sign or things like that. And here's an example that I showed before. It works. All right justified. And as I said, the first entry needs to have be shifted one character spot to the right. So my decimal aligned situation, what I want to develop is a counted string with the decimal points arranged in a columnar position. The words that do this built on what I just did before. The paren f dot a is a sort of a primitive. It does the conversion given the number of the column position where we want the decimal and the number of decimal places. So if we want the decimals to align at, say, the fourth column, we would put in 4. And if we only want 3 digits, we put in 3 for a decimal conversion. And so the mumbo jumbo there, the dupe swap and all of that sets it up. And then we just do the right justified f.r. The f.a takes that counted string and outputs it. And sure enough, out comes column aligned decimals. And notice by using the built-in fourth paren f dot, the primitive of the f dot, the decimal round off is handled properly. And this was a surprise to me. At the beginning, I thought I'm doing this kind of quick and dirty. I thought I would just have to truncate for round off. But in this case, it actually does the correct round off to the nearest, nearest round off. So when you see the 123.5, that actually is a 123.4, but it's rounded up to 5 because the next digit is 6. If you look at the 123.6, it's really 123.5, but it's rounded up because the next digit after that is 6. So, and the remaining digits then are to the precision we specified. So this was a pleasant surprise. The heavy lifting is done by that fourth string conversion, which handles the round off. And I can't remember if they use the floating point chip to do the round off or if they do it by fourth. And I think the fourth software due to Bob Smith does the round off. So here's a summary. We're almost done. The tools are available within Win32.4 to do the floating point conversion. That is, the raw components are there. It took a significant amount of effort to decode this because it was hours, because I had to go back and some of it was in assembly language, a little bit of it that was calls to the fourth chip or to the floating point hardware that's in the CPU. And then I had to find this mysterious calling formats that are used and then try to figure out which primitives I could use and would be useful and not. And once I'm all done, now it is quite direct. It's a piece of cake to do. The thing that we missed is that for our integer conversions, we have these beautifully thought out and effective of the greater hash hash AX half greater than that we do output integer strings, but there's nothing even close to that for floating point numbers. Currently, you've got to go into the primitives and work it out yourself. In an idle moment, I may try to develop some general purpose primitives that would do this job. And as a sidelight, the built-in F dot uses this clever buffer handling process to avoid creating the floating point text buffer. What I found out is in Win32.4, there's a user variable called pad, and pad to the left is used for output number formatting. Pad to the right is a buffer of about, I think it's 250 bytes up to the right, and it's unused. The only time it is used ever anywhere is on the greeting message. When you start the program, the greeting message puts the version number in that pad and does a conversion there. And that is the only use made of pad values to the right. So I have adopted that now to use for the number conversion. And of course, it is only in use in between words where you're passing that string from word to word. So that was my little user discovery. Feel free to use pad from the upper end, and also if you're using pad downward, if you're doing integer conversion, that's the only time it's used. So as I just said, pad is a good buffer space. So that concludes my remarks, and I will turn it back to Action Central. Kevin, thank you so much.
Thank you, Bill. Are there any questions at this time?
Wonderful. We're in stunned silence. That is great.
Is this a chapter in your book, Bill?
It's a component. As I find tools, I add them in, and there's an appendix that has words that I've added in. For example, I found that there's a bug in the GoToXY when you're plotting on screen. If you do a clear screen, the next GoToXY will be invalid. So if you do a clear screen, you've got to do a false GoToXY, and then everything is good after that. So you either have to patch clear screen or you have to patch GoToXY. And so that's a discovery. It's the only thing I found in Win32.4 that is exceptional. And so that's in my book. And then a string concatenation missing, this number conversion, and a few other tools. So and I originally thought the book was going to take 3 or 4 months. Well, as software programs go, Mythical Man month, every month it's taking 3.5 weeks longer. So it's a 2023 project at best. So that's it. Thank you, Kevin. Thank you, team.
We can't say how grateful we are to you for all your efforts on our behalf, Bill. And this is just the latest episode adding to that debt of gratitude. So thank you, Bill.
Well, I've got the floor. Let me tip a little bit about the future. On the 4th 2020 Facebook page, they've made a challenge for upcoming months, not necessarily the next month, but it's to program in Forth elevator system for a building. It's a pretty general challenge, and the people who are talking about it are kind of thinking about more of a hardware version where you use a one-chip computer to do it, but I'm doing a pure software emulation. So you might go read on the 4th 2020 page, because it'll be a lively topic at that site. And we may adopt this later on and let people do a presentation here on this site. Because I've got it programmed, I got about 80% done, and it is really fun and it is really intricate, because when you're allocating travel between floors in a building, you don't know when call requests are going to come in from what floor, and you've got to handle the up people, the down people, you've got to open the door at the right time, and so on. And so It's a very interesting dynamic problem, and so expect to hear more about it in the future. So that's all for now. Thank you.
So when you say 4th 2020, that is the Facebook group of that name?
That's correct. Yeah, Facebook. Good.
All right. I looking down the list, I think everybody here knows that, but this is going to be a YouTube video that may last for posterity. So it's a much more active environment to talk about 4th, and I'm so glad that they're there. All right. Anyone else have any comments? Brett, you're live.
Yes.
Welcome.
Thank you very much. Yeah, I was just zooming in. Don Golding from Core One invited me to this meeting. And I just logged in. I had a lot of stuff I was doing today. I'm just really busy, and so I figured I'd log in now. So what's the general synopsis of everything that's been going on? Just really simple.
Okay. The first talk was Bill Ragsdale talking about floating point number output. The next speaker and subsequent speakers are all listed on our meetup. That's the easiest way to get to our agenda.
Mm-hmm.
And we will be going to the next talk now. Anybody, announcements, comments, rumors, gossip? All right. The t-shirt for today is my long sleeve FranLab t-shirt. I can see by the camera that it doesn't come out well on camera, so we'll be working on that for a later interlude. All right. So Ed Boraski, it's your turn.
Yo.
Introduce yourself and on with the show.
Okay. Should I share my screen now or wait till?
Yes, that would be good. And also, if you're not.
Kevin, you're muted.
Kevin's muted.